Hello, my name is Rain. I'm a TA for Chem, and this is the first video in a video series about the gas laws. So this is going to be split into 3 video units, and each video unit is going to have a few videos. So for the first video unit, we're going to be covering Boyle's law, Charles' law, and Avogadro's law. And this video is just on Boyle's law. Scroll. Oh, sorry. Okay. So this is Robert Boyle. So Robert Boyle is born in 1627. He died in 1691. He was a prolific scientist and philosopher in Ireland, but he also worked in England. And he is the creator of Boyle's Law. So in this experiment, as you can see, he trapped air in a J-shaped tube and then added mercury to increase the pressure on the air, along with atmospheric pressure. And he found that the volume of the air in the smaller end of the tube here would decrease if pressure increased. So this gives us Boyle's law. Volume is inversely proportional to pressure at constant temperature and amount. So that is, if we're not increasing or decreasing temperature and the amount of gas we have is constant, when we decrease the volume, the pressure of the gas is going to increase and vice versa. Sorry, the slides are misformatted, but this first equation just represents that. So volume is inversely proportional to temperature. So this is the proportion symbol. And while this is good for looking at it in theory, in practice, we can derive this equation. So since volume is inversely proportional to pressure, we can say that volume is equal to a constant times 1 over P. So from that, we get initial pressure times initial volume is equal to final pressure times final volume. This is because they are in a constant ratio. Sorry, the slides are... Okay. And let's try this first practice problem. So there is gas trapped in a piston with a current volume of 2.4 liters. The pressure the gas is currently exerting on the container is 3.2 atm. If the volume is increased to 3.0 liters, what pressure will the gas exert on the container? So right now we're just looking at volume, as you can see, liters, and pressure from atm. So we're going to use Boyle's law. P1 V1 equals P2 V2. So we start with a current volume of 2.4 liters. So this is our V1. The initial pressure is 3.2 atmospheres, our P1, and our hypothetical volume increase or to our final volume is going to be 3.0 liters. So V2. So we can plug this into the equation. P1, 3.2 atm times 2.4 liters is equal to P2 times 3.0 liters. So, and just to clarify, the reason that the gas is exerting pressure on the container is because the molecules in the gas are kind of knocking around, knocking into each other, and knocking on the container. So pressure, it's applying force to the interior of the container. So now we can just algebraically work on this equation. So allow me to pull out my calculator. So we can just get that P2 is going to be equal to 3.2 ATM times 2.4 liters over 3.0 liters. So we'll cancel out our units, and then let's plug this into the calculator. 3.2 times 2.4 divided by 3. So our final pressure looks like is 2.56 ATM. And one thing we can do to check our answer is look at the relationships. So our final volume is larger than our initial volume. There was an increase. So since pressure and volume are inversely related, we know that means that since the volume increases, the pressure is going to decrease. And 2.56 ATM is indeed smaller than 3.2 ATM. Okay.
Hey guys, really quick, I'm so sorry. I just realized I forgot to round to the appropriate number of sig figs while I was doing this problem. Since we have like 2.4, 3.6 in our units, that's only 2 sig figs, so we should also round our answer to 2 sig figs. So 2.56 should become 2.6. So always remember to be careful with your sig figs, especially for the AP exam.